Today's lesson is on adding, subtracting, and dividing scientific notation. First, we'll look at our rule for adding and subtracting scientific notation. To add or subtract numbers written in scientific notation with the same power of 10, add or subtract the factors. First, we'll look at a couple of examples for adding scientific notation. We're going to add, and then we want to write our answer in scientific notation. So for number 1, we have the quantity 3 times 10 to the 7th power plus the quantity 2 4/10 times 10 to the 7th power. I have the same power of 10. I have 10 to the 7th power for both, so I can go ahead and add my factors. So I'm going to add 3 plus 2 4/10. And that answer would then be times 10 to the 7th power. 3 plus 2 4/10 is 5 4/10. So I have 5 4/10 times 10 to the 7th power. Now let's look at number 2. For number 2, I have the quantity 4 6/10 times 10 cubed plus the quantity 8 72/100 times 10 cubed. I have the same power of 10, so I can go ahead and add my factors. So I'm going to add 4 6/10 plus 8 72/100. And that answer would then be times 10 cubed. When I add 4 6/10 times 8 72/100, I'm going to get 13 32/100. And that would be times 10 cubed. 13 32/100 is not correct for scientific notation because my factor should be at least 1 but less than 10, and 13 32/100 is greater than 10. So I need to convert 13 32/100 into scientific notation. In order to do that, my decimal should be after my first non-zero digit, which means it should be after the 1. So I have to move my decimal to the left 1 place. So I'm going to have 1 332 thousandths times 10 to the first power. And then I have times 10 cubed for the rest of my problem. Now I can use the product of powers property to combine 10 to the first power times 10 cubed. So I'm going to have 1 332 thousandths times 10, and then I'm going to add my exponents. 1 plus 3 is 4. So my answer is 1 332 thousandths times 10 to the 4th power. Next, I'm going to look at a couple of examples for subtracting scientific notation. I'm going to subtract, and then I want to write my answer in scientific notation. So for number 3, I have the quantity 9 2/10 times 10 to the 8th power minus the quantity 4 times 10 to the 8th power. For this problem, I have the same power of 10, so I'm going to go ahead and subtract my factors. So I'm going to subtract 9 2/10 minus 4. And that answer would then be times 10 to the 8th power. 9 2/10 minus 4 is 5 2/10. And that would then be times 10 to the 8th power. So my answer would be 5 2/10 times 10 to the 8th power. Now let's look at number 4. For number 4, I have the quantity 3 5/10 times 10 to the negative 2nd power minus the quantity 6 6/10 times 10 to the negative 3rd power. For this problem, I will notice that I do not have the same power of 10. So I'm going to have to convert either the first number that's in scientific notation so that I have something times 10 to the negative 3rd power, or I have to convert the second number in scientific notation so that I have something times 10 to the negative 2nd power, so that I then can combine my scientific notation. For this problem, I'm going to go ahead and choose the second part of my problem to convert. So let's first just work on that part. So I have 6 6/10 times 10 to the negative 3rd power. I want this to be something times 10 to the negative 2nd power. So I can go ahead and change my 10 to the negative 3rd power, and I can change that so it is 10 to the negative 1st power times 10 to the negative 2nd power. My product of powers property tells me that I will add my exponents. So I will add -1 plus -2. And that would give me -3, and that's what I had in my original part of my problem. So what I have is 6 and 6/10 times 10 to the negative first power times 10 to the negative second power. I just want 10 to the negative second power, so I'm going to go ahead and simplify this part of my problem. 6 and 6/10 times 10 to the negative first power would be simplified to 66/100. Since I have the -1 for my power, I'm going to move my decimal to the left one place. So I have 66/100 times 10 to the negative second power. Now I can go ahead and continue working on my problem. So now my problem is the quantity 3 and 5/10 times 10 to the negative second power minus 66/100 times 10 to the negative second power. Now I have the same power of 10, so I can go ahead and subtract. So I'm going to subtract 3 and 5/10 minus 66/100, and that answer would then be times 10 to the negative second power. 3 and 5/10 minus 66/100 is 2 and 84/100, and that would then be times 10 to the negative second power. Now I'll look at my rule for dividing scientific notation. To divide numbers written in scientific notation, divide the factors and powers of 10 separately. Now I'll look at a couple of examples for dividing scientific notation. We're going to divide, and we want to write our answer in scientific notation. So for number 5, I have the quantity 6 times 10 to the 4th power divided by the quantity 3 times 10 to the 4th power. First thing I'll do is I'll go ahead and write this out as a division problem, or I can write it as a fraction. So I have 6 times 10 to the 4th power, and that would then be over 3 times 10 to the 4th power. Now I want to divide my factors and my powers of 10 separately. So I have 6 divided by 3, and that's times 10 to the 4th divided by 10 to the 4th. 6 divided by 3 is 2, and then I have times, and when I use my quotient of powers property, I know that I'm going to subtract my exponents, and 4 minus 4 is 0. So I have times 10 to the 0 power. I will not simplify 10 to the 0 power because I want my answer in scientific notation. So my answer is 2 times 10 to the 0 power. Now for number 6, I have the quantity 1 and 5/10 times 10 to the negative 8th power divided by the quantity 6 times 10 to the 7th power. So first I'm going to write this out as my fraction. So I have 1 and 5/10 times 10 to the negative 8th power, and that is over 6 times 10 to the 7th power. I need to then separate my factors and my powers of 10. So I have 1 and 5/10 divided by 6, and that is times 10 to the negative 8th power divided by 10 to the 7th power. When I divide 1 and 5/10 by 6, I'm going to get 25/100, so 0.25. And then I have times 10, and then to figure out my exponent, I use the quotient of powers property, which tells me I subtract my exponents. So negative 8 minus 7 is negative 15. When I look at this answer, 25/100 times 10 to the negative 15th power, I will notice it's not correct for scientific notation because 25/100 is not at least 1. So I need to convert 25/100 into correct scientific notation. In order to do this, my decimal would have to be moved after the 2. So I'm going to move it over to the right one place. So 25/100 would be the same thing as 2 and 5/10 times 10 to the negative first power. And then for the rest of my problem, I have times 10 to the negative 15th power. Now I can use my product of powers property to combine 10 to the negative first power times 10 to the negative 15th power. So I have 2 and 5/10 times 10, and I add my exponents, negative 1 plus negative 15, and that is negative 16. So I have 2 and 5/10 times 10 to the negative 16th power.